Welcome to our presentation of SUNY, a visual interpretation framework for convolutional neural networks from a necessary and sufficient perspective. This is a collaborative work by the University of California, Davis, and National Taiwan University. Saliency maps are widely adopted for CNN interpretation, aiming to highlight the most important input features for model decisions. However, existing approaches often focus more on model parameters, overlooking the fundamental why behind their decisions. Aligned with counterfactual thinking intrinsic to human cognition, SUNY rationalizes CNNs from the causal sufficiency and necessity perspective. Our method considers the input features as hypothetical causes and the model's predictions as outcomes. The causal necessity, N, is measured by the outcome differences when changing the causes, while sufficiency, S, is measured by the outcome stability when specific causes are unchanged. Inspired by Shapley values, we define the NS Shapley values to quantify the causal importance of input features bidirectionally. Our framework starts with a forward pass through the CNN to extract feature maps. Then we obtain corresponding input features and perform interventions by removing or keeping them respectively. Following the definitions, we compute N and S Shapley values. The necessity and sufficiency heat maps are constructed by the weighted integration of feature maps. We evaluate SUNY on 2 benchmark datasets using 3 different CNN architectures, where we compare SUNY with 7 baseline methods to assess its effectiveness in providing class discriminative explanations. The quantitative evaluation with metrics such as the deletion insertion and energy pointing games indicates SUNY's superior performance over competitors. By visually comparing with others and validating the sanity check results, SUNY's capability of providing high-quality explanations can be further proved. Please check out the full paper for more details.